Hi, Danielle. I wanted to go through this analysis for the chi-squared test on your data. So I took the data set that you gave me and I erased that weighted chart at the bottom. What I'm going to do is I'm going to go through the data that you have without combining the hair types. I thought about it a little bit, and kind of the rationale is that it's really twofold. First, as we were saying today, whenever we begin to combine data, we lose information. But secondly, when you combine data, you're kind of saying that you know that these two things are the same. And I'd be a little reluctant to say that I know that these two type of hair types are kind of the same, or they're perceived the same. In other words, we might think that straight's perceived the same as wavy, but that may or may not be, right? So I'm going to take that point of view. Okay, so I'm going to go up to your table here, and we'll go ahead and we'll compute the row sums here. I'm just going to go across here and do the row sums, and then I'll bring this down like this. Okay. And you've already done the column sums right here, so there's no need to do any more. And it's kind of interesting. You have a very interesting design because you have the same number in each category. That is very interesting. Let's just make sure I believe that. Yep. So you got what? 39 and 4 is 43. So yeah, so you have 57 of each type. Okay, so you have a really good design. And let's do it for the females first, okay? So we said that what we're going to do is we're going to create this table down here, and I'm going to add one column right here because I'm going to put the percentage, the relative percentage of each row. All right, so we said that, and we know what this is going to be. This is going to be 1/4. They're all 1/4 because of the way that you have your counts set up, which is really good. Okay. I'm going to put a little $sign so I can anchor this value here, and that way when I drag it down, it won't move the 228. Okay. So if we go back and we remember the rationale behind the chi-squared test. The chi-squared test says, in the context of this problem, if, for example, hair type 1 has no effect on the position of power, then since 1/4 of these people have type 1 hair, and we have 57 people in this group, then basically 1/4 of them should be in this cell. That's basically what it's saying. So I'm going to go ahead and I'm going to go back and I'm going to construct the expected counts. These are the observed accounts. I'm going to go back and construct the expected counts. So I'm just going to recopy the table, put it down here, and I'm going to paste them as values and then take out all this. I don't need all this. Okay. So these are going to be my expected counts under the null hypothesis. All right. And if it's okay, I'm going to use, we sometimes abbreviate the null hypothesis as H sub 0. All right. And this is going to be my table. So I'll color this in. Let's see. All right. This. And I'm going to take out everything in the interior. I'm going to go ahead and compute the expected counts. So this is that mmult command. So I'm going to go ahead. I'm going to highlight this whole table. Okay. Because I have a 4x1 times a 1x4. So I'm going to get a 4x4 matrix. And I'm going to say equals mmult. Click on that. And the first person being multiplied is always going to be the percentage column here. And the thing that's going to multiply are going to be the counts from the columns. Okay. And then we close this off. And we remember that what the guy said on the video is what you then have to do is you have to hit Control-Shift-Enter. So I'm going to hold down Control-Shift and hit Enter. And those are my expected counts. And you can see it's exactly what we know it should be. It should be 1/4 of 57. And that turned out to be 14.25. So now what we're going to do is we're going to look at the discrepancies. This is what we observe. This is what we expect under the null hypothesis. And I want to look at the really, in a sense, kind of the measure of the difference of how much these change. And so what I'm going to do now is I'm going to compute the chi-squared statistic, okay? I'm going to compute it for each cell. And the formula is going to be that it's going to be the expected minus the observed squared divided by the expected. So here's what I'm going to do. I'm going to copy this table again. Okay. And put it down here. I'm going to paste it as values. Okay. And so in each of these cells, we're gonna for each cell we're gonna have the expected, and I'm just going to use E for expected, okay, minus the observed counts squared divided by the expected counts. And I have to be careful because Excel thinks this is a formula when I type equals, okay, but that's what's going to go in each cell. So let's go ahead and try that. So the first cell is going to be the expected number of counts is 14.25 minus the observed, which is 15. I'm going to square that, and then I'm going to divide by the expected. Okay? And then I can just drag, right? The drag command will just work for the whole table. Okay? I pull this down like this. And this tells me the discrepancy. And so you can see where the discrepancy is large. For example, if you look here in the cell 2-2, you can see that it's very different, right? Here it's only 1 was the observed and 14.25 is the expected. So if you look here, you see this discrepancy is really large, right? And so I want to measure the overall discrepancy. This is telling me basically kind of the discrepancy on a cell-by-cell basis. So I'm going to add them all. So I'm going to compute this thing now called a chi-squared statistic, and it's going to be the sum of all of these chi-squared contributions, okay? So I'm just going to sum them all up now. So here we go. So it's going to be equal to sum. And I'm just going to highlight this whole table, right? I want to sum them all up. Now, I will tell you without even doing any analysis, that's a very, very large chi-squared statistic. And here's how you can tell. So what I want to do is, and this is what we were talking about today, I want to ask myself, what is the probability that I could see this large a value if the null hypothesis was true? And this is what we call the p-value. So the p-value, what it actually represents is it tells me how likely I am to get a value this large or larger if the null hypothesis was true. And so the way I calculate this p-value is I type this command. This says, okay, call up this thing called a chi-square distribution, and I want to look in the right tail. In other words, this is actually what we're talking about in class right now. I want to know what is the probability in the right tail. And we're going to talk about this tomorrow, actually, which boils down to what is the upper percentile. So I'm going to click here. I'm going to enter this value. Now I have to enter the degrees of freedom. So the degrees of freedom end up being 9, and I'll explain how I know that, okay? And I hit this. This p-value is extremely small. This p-value is 2.65 times 10 to the minus 17th, okay? That's point with 16 zeros, a 2. This number looks like this. just to kind of emphasize. Let me not do that. Maybe I won't emphasize. But this is an extremely small number. So this is very strong evidence that there is a significant effect. This is very strong evidence that there is an association. Okay? Now, I wanted to show you how to get the degrees of freedom. So this thing called the degrees of freedom that I put into this calculation, notice that this second number is the degrees of freedom. Okay? Here's how I get it. And if you don't mind, I'm just going to abbreviate these degrees of freedom equal DF, okay? It's equal to the number of rows minus 1 times the number of columns minus 1. All right. So in our case, we have 4 rows, so I'm going to have 3 times 3. And that's what I put in here. Okay. So this is that part there. Okay. Now you asked a really good question, which is, how do I show this visually? And this is very important because the idea is we want to plot the data first, and it's the plot of the data that actually suggests that we should do some analysis. So we can do a bar plot here. And to do the bar plot, we can do it a couple of different ways. I'm going to do a bar plot right from here. I'm going to try to do this with Excel, okay? Let me just think for 1 second. I'm going to go to Insert, and I'm going to do a bar plot here, okay? And I want to do, let me think about this for 1 second. Yeah. I want to make sure I understand. So I'm gonna take your data. I'm gonna code it a little bit different, okay? And the reason why is I have 1, 2, 3s, 4s. I have too many things going on. So I'm gonna call this T1, T2, T3, and T4, just so I know. In other words, that these 1, 2, 3, 4s are different than these 1, 2, 3, 4s, okay? And now I'm going to plot it. So we always go to Insert and the plot, and I can click on this, okay? And this isn't showing me what I want. I actually want, this is showing me in each of the, this isn't a bad plot, but I want to do this plot a little different, okay? What I want to do is I actually want to plot these as being the groups. So what I'm going to do is I'm just going to go down here for a second. I'm trying to think if there's an easy way I can do this in Excel. I know one way I can do it, but I want to just try to use this table. So let me see real quick. I have to figure out how to group these things, okay? Yep, that's what I want right there. Okay, so notice what's going on here, okay? This is showing that for position number 1, okay, where I have 57, notice that this hair type here is occurring very, very little. So this is very strong evidence that there's definitely an association between hair type. There's a very, very strong association. Notice that hair type 3 definitely occurs with position 2 more than it occurs at position 4 or 3. Okay? So this is definitely evidence. And so what we do is we do the graph first. We look at this, we say, wow, it looks like this hair type really goes with this position a lot more. Then that's evidence to do the analysis, okay? So this is the plot. So let me explain what I did just very carefully, okay? So the reason why I put the hair types in different letters is because I had 1, 2, 3, 4, 1, 2, 3, 4, and I couldn't tell which was which, okay? And the idea is that you can plot this 2 ways, but what I'm really interested in doing in chi-square is I'm interested in looking at each column. I want to plot all the hair types for each position of power. And so you notice there's 2 ways I can do that, okay? I can, if I go to Insert and I go up here, And what I actually did was I played around with both of them. This is where it actually gives you two possibilities. It doesn't really explain it's doing this, but notice here's where I'm grouping them, and the groups are the hair types. So here it's looking at the rows, right? Notice here it's looking at the columns. It's grouping it by power type or position of power, okay? And our chi-squared analysis, in a sense, is looking at really the position of powers. This is how I'm thinking about it, right? And that's how we got that. So this is how we do the graphical analysis. This is how we do the chi-squared analysis. Again, I strongly suggest that you keep each of the hair types. You can see that there's definite differences, okay? Notice that if you group 3 and 4, you would actually wash out this part right here. See this? If you group them, you would actually, in a sense, kind of homogenize them. You would take away this really extreme value here, okay? So I would keep it the way it is. I think it's definitely going to improve your test. So this is going to be a YouTube video. I'm going to send this to you. You can watch this. And if you have any questions, please feel free to contact me. You can Skype, we can talk, whatever. And I think you have a really good project. It's very exciting. And I want to thank you for involving me in this.